Alright, and we are on to the last part of 7.1, 7.1 part 3, which is exterior angle measures. So here's the big thing, okay? In general, exterior angles look like this. Here's our polygon, it's a triangle. Oh man, okay? Perfect. This angle right here is going to be our exterior angle. So if I take it and I extend all the sides in that way, there's going to be exterior angles all over, okay? Those are called exterior angles. So what we're looking for here is we're going to look for the number of exterior angles that happen in general, okay? And so let's continue with our process here. Let's look at this like it was a regular polygon, okay? This is a regular polygon. This means that all the angles in here are 60, right? Because it's a perfect triangle, equilateral, all the sides are the same, all the angles are 60, right? Because there's a triangle, it's 180, 180 and minus 2 divided by n, you get 60, okay? So this is a perfect regular triangle. It's not very nice. So, if you're looking for this exterior angle, what relationship does this angle right here and this angle right here have? Okay? In general, that is a linear pair. Remember, those two angles are adjacent and supplementary, which means that they add up to 180. So, if this angle right here is 60, then this one is 120. Right? Now they make 180. Now if this one is 60, this one's also 120. Same here. Okay? And those are the three exterior angles. And so if you're looking for the sum of them, it'd be 120 plus 120 plus 120, which is 360. Okay? Now if I really wanted to bore you, I would do this for every shape. That's for a triangle. Do it for a four-sided figure. Okay, we can briefly do it really, really quickly. Here's a square. Extend all the sides the same way. Now on the inside, these are all 90 degrees, right? But if this is 90 degrees, what is that? Well, it's also 90 degrees. Same with this one. Same with this one. Same with this one. Okay? And in this case, it'd be 90 plus 90 plus 90 plus 90 for all the exterior angles put together, which is also 360. Now you might see a pattern here. On the inside, this was 180, this is 360, 540, and so on. But look what's going to happen. As the inside grows, the outside's going to go smaller, right? This was 120, now this is 90. And so it's going to equalize. It's going to be 360 always. So in general, we're looking at this. Here's a polygon. The measure of one interior angle, we did this the other day, it was 180 times 3 minus 2 over 3, which is 60. Okay? In general, this one formula right here is going to be 180 and minus 2 over n. Okay? That's going to be 60. Now, we talked about one exterior angle. We just did this. Right? That would be 120. Okay? The number of exterior angles, there's going to be 3 of them. And the sum is 360. So here's what we're going to do. We're going to go from that chart from last time. Try to find it. 2 times ago? 2 times ago. Okay, what I'm looking for is this chart right here. And I'm going to copy down the measure of one interior angle, because we did this already, right? I'm going to copy that down. So, measure of one interior angle for a triangle was 60, for a square was 90, pentagon was 108, hexagon was 120, and is this 1, 2, 3, 4, 5, 6, 7, 8. So an 8-sided figure is 135. Okay? So we have all of the polygons that we want there. And so now what they're doing, like the picture I just drew, is they're zoning in just on one piece. They're saying, oh, this is 60. So if I extend it, these two make 180. And so this one's 120. So they're going to do that for all of them. And in general, an exterior and interior angle are always going to be linear pairs. So all we have to do to fill out this column right here is take 180 minus this number. Okay. So for this one, it was 180 minus 60, that's 120. Next one, 180 minus 90, that's 90. Again, all these are degrees, of course. Okay. Next one, 180 minus 108, don't want to mess up in front of you, 72. I don't know why I put a line through my 2, I don't know what's wrong with me. This one's 60, and this one is 30, not 35, 180 minus 135 is 45. Okay, I'm going to degrees all these so I don't feel so bad. Okay, pretty simple as far as calculating those goes. Okay, now let's look at the number of exterior angles. This was 3, this has 4, this has 5, this has 6, and this has 7. Corresponds to the number of sides, right? And so the sum This is pretty funny. Okay? Now look at this one. There's 120 for one of them, and there's 3 of them. So you take 120 times 3, you get 360. We're going to multiply these, all of them. This column right here and this column right here. 120 times 3, 360. 9 times 4, 360. 72 times 5, 360. 60 times 6, 360. Whatever this is times whatever this is, take a guess. 360. Okay? No matter how you look at this, the sum of the exterior angles of a polygon is going to be 360. That's because, as you notice, as the measure of the interior angle goes up, the measure of the exterior angle goes down. Okay? And so that's why it's equalizing at 360. So the sum of the measure of exterior angles is 360 degrees always. That'll be a trick question. Okay? Because you're going to run it through a formula or something, and just the sum is always 360. Okay? Let's go to the next page. I got lost. Hopefully this is the next one. That's page 7 or page 8. Perfect. So, for the theorem, the sum of the measures of the exterior angles of a convex polygon, one at each vertex, is 360 degrees. Okay? Put degrees there. So in this example, we have 5 pentagon. All those angles added up, no matter what they are, must be 360. Okay? So we're going to use that. Find the value of x. We have 1, 2, 3, 4, 5 angles. So we know that all those angles are exterior angles, so they add up to 360. So go ahead. 90 plus 60 plus 4x plus x plus 2x had better be equal to 360. Combine like terms and solve. So we have 150 plus, 7x equals 360. 7x equals 210. X equals 30. And that's all there is to it. Okay, exterior angles add up to 360. Example 2. Sarah, I don't know who Sarah is, notices that a lamp at her house has a base that is a regular 15 gon. Find the measure of each interior angle. Each interior angle. Now remember, from before, part 1, that is 180 n minus 2 over n. So in our case, we have 180, 15 minus 2, 15 is the n, over 15. Pretty big number. 180 times 13 divided by 15 is 156. Okay? Each interior angle of this is going to be 156 degrees. Now we want to find the measure of each exterior angle. We talked about this from the chart, but the interior and exterior angle are always going to be linear pairs. So all we have to do is 180 minus 156, which is what? 24. Okay? And that's the answer. Nothing to it. Alright, 2 more examples, and then we finally finish 7.1 after 3 days. So, example 3. The measures of the exterior angles of a convex pentagon are 2x, 4x, 6x, 8x, and 10x. Which one is the smallest, and what is the measure? Okay? Now, it's tricky, right? But it's not. What is the sum of the measure of the exterior angles of a convex pentagon? Well, always, always, always is 360. So we're going to add them all up. Is that equal to 360? Combine like terms, we have 6, 12, 20, 30. So x is 12, I think. I don't want to butcher this and lie to you. Yeah, x is 12. Now, the worst part on the test, half of you put 12. Break my heart. Okay? The answer is what is the question is what is the measure of the smallest? So we need to take this and plug it back into the smallest one, which is 2x. So we have 2 times 12, which is 24 degrees. That would be your final answer. Okay? And on to the last one. Example 4, how to find the exterior angle of a regular. Again, this is the regular polygon. So it says, what is the measure of one exterior angle of a regular 13 gon? Now here's the thing. Remember, regular polygons always have the same inside angle, right? Always. And so if it was like a nice triangle like this, right? These were all 60, and so these were all 120. But if it's like this, where it's a right triangle, now they're going to be different sizes. So they're still going to add up to 360 on the outside. Okay? So here's the key. If you have a regular polygon, all the angles are the same. So the sum is still 360. But now to find one exterior angle, we know all the outside ones are the same. We know there's 13 of them. So all we have to do is take 360 divided by 13. What is that number? Super nasty. 227.6923 and so on. Okay? But that would be the measure of one exterior angle. Okay, because in total, they need to multiply to be 360, and there's 13 different ones. Okay, so that's all you have to do is take 360 in general, take 360 divided by n, and that'll give you one exterior angle. All right? And that finishes off 7.1. Thanks for watching.